Welcome back to Mr. Slover's Math. Today we're going to focus on solving two-step equations with like terms. And the target is you can solve multi-step equations. So it could be two steps or it could be more. It just depends on the problem that we encounter in today's notes. So this warm-up is getting us ready for what we're going to do, because up here it says we're going to collect like terms. We're going to solve equations with like terms. So the warm-up says simplify the following expressions. All of these have no equal sign. By definition, that's what an expression is. There's no equal sign. So that means we are just collecting like terms, same variable and the same power. So I highlighted my like terms in every single example, and I collected the ones that I needed to. So I want to draw your attention to letter E, where it says m plus 3 minus m plus 12. So my like terms are the m and the negative m. Now remember, you're taking that sign that's in front of it. You maybe think, well, Mr. Slover, that doesn't say minus, it doesn't say negative, it says minus. Well, think of a minus as a plus negative. They mean the same thing. So m minus m, what I wrote down here, 1m minus 1m is 0. There's no more m's. Those m's cancel out. All I'm left with is the 3 and the 12, which happen to be like terms, which is why I highlighted them. They're both constants. So 3 plus 12 is going to give you 15, and that's your answer. There's nothing else to do. Those m's are gone. Okay, so keep this in mind of collecting like terms as we work through these problems. So it says when solving two-step or multi-step equations, your goal is to get the variable isolated. And to do that, you're going to undo the order of operations. So it means you're going to add or subtract before you multiply or divide. So once again, I want to stress that what I wrote here is for the notes that we are doing and the homework assignment that you have. This is not always the case. There could be questions where adding and subtracting is not your first order of operation. You may have to multiply or divide to solve first. But for all the problems I'm giving you, we're going to focus on following this. All right, so number 1, solve the following equations. Work is required. So over here in red, I've got, it says same side of the equal sign. So here's my fence that I've talked about before. And if need be, take your finger and cover up the left side of that fence and see if you have any like terms. So right now I'm covering up 3, so I don't think I can combine that with anything on the right side. So when I cover it up, I have a 1 minus 3n plus 4n. And I see that the negative 3n and the 4n are like terms. They both have the same variable and they both have the same power. So I can combine them. Negative 3 plus 4 gives me 1n. Now notice I just wrote n. You can either write 1n or n. That is totally up to you. It's a personal preference and it's your choice. Okay, so I had my finger on the left side to see if there was like terms. There were. I collected them. And we do the same thing for the other side. Put my finger over the right side of the equal sign and I cover everything up, so all of this would be covered up. And I check to see if I have any like terms, and the only number over there is 3. So I know I don't have like terms. Now you may be thinking, Mr. Slover, that's kind of silly to cover up both sides when one side only has one term. Well, I'm trying to get you in the habit of always checking both sides, because eventually you will have both sides that you may have like terms on. Okay, so it's good to get in that habit now. Okay, we collected our like terms, and we're left with 3 equals 1 plus n. So once again, our goal is to get the variable by itself. So this is a positive 1, 1 plus n. The assumption is if there's no symbol in front of the number, that it's positive. So I need to subtract 1 from both sides. 1 minus 1 is 0. That's why I was able to cross it off. That's gone. What I do to one side of the equal sign, I have to do to the other side. So if I'm adding or subtracting on the right side of my fence, the red line, I have to do the same thing on the other side. So 3 minus 1 gave me 2, and then on the right side I'm left with just the letter n. Now some of you are looking at it and say 2 equals n. That doesn't seem right. Well, you can switch it around. 2 equals n is the same as n equals 2. If we think about it not in terms of math, and you have a dollar bill, look at the front side of the dollar bill. Turn it over, look at the back side of the dollar bill. Still a dollar bill, they just look different. This is the same concept. 2 equals n, and n equals 2. It's the same thing. Okay, so here's another example. If you want to look through that one, you are more than welcome to. I want to look at letter C. So I highlighted my like terms. So once again, I drew my fence in there. I took my finger, I covered up the right side. Saw that the 4n minus 5n are like terms, same variable, same exponent. I combine them. When I combine them, I get 4 minus 5. I have to take that sign with it. 4 minus 5 is negative 1, or negative n. If you want to write negative 1n, that's fine. And then on the right side, I only have a 4. So I don't have any like terms over there to combine. So I'm at negative n equals 4. Well, that negative n, we've seen that before. Negative times a variable is what it's saying. So negative 1 times n equals 4. So what I'm doing is I'm dividing, I'm undoing that multiplication with division. I'm dividing both sides by negative 1. So 4 divided by negative 1 is going to give me negative 4. And if you want to check your answer, take negative 4, substitute it back in, see if you get 4. And you should. If you don't, you did something wrong. Letter E. So I drew my fence in there. I cover up the right side. I don't have any like terms. Cover up the left side, and I do have like terms. A negative 5n plus 6n. So negative 5 plus 6 is going to give me 1, and I still have that n, so 1n. And then this 6 drops straight down. Now this is a positive 6. It's saying 6 plus n equals negative 5. I want to get rid of this positive 6. In order to do that, I have to subtract. So 6 minus 6 is going to give me 0. I'm left with n, which is what I wanted. I wanted that variable isolated all by itself with nothing else there. So I subtracted 6 from the right side. I have to subtract 6 from the left side of the equal sign as well. So negative 5 minus 6 is negative 11. And then on the right side, we have the letter n. So n is negative 11. And notice on letter F, you get a decimal, and that's okay. If you got questions, make sure you're reaching out and asking.